All right, you guys, Unit 5. This is all volume. This, apparently slide 6 is area and circumference of circles. So this is something you've done since middle school. But of course, high school is a little bit different. So let's get into it and see what they're asking us to do. All right, so I'm going to open up my GeoGebra. Huh, interesting. What's that do? Oh, cool. Look at that. Oh, and it gives me the circumference as it goes for the diameter. Nice. All right. Okay, if all these instructions fill in the table for different values of the diameter, radian inch to the nearest hundredth. All right, so move the slider, roll the circle. As you roll the circle, circumference of the circle unfolds along the x-axis and the length of the circumference appears below. Once you have completely rolled out the circumference, fill in the table for the specified diameter you used. Roll the circle back to its original position. Change the diameter by moving the blue dot along the y-axis. Repeat these steps. Okay. So I said it was a 4, right? You see, yeah, your diameter is 4. I'm going to unroll this so I can see what my circumference is going to be. Bam. So 12.57. All right, the ratio of the circumference to the diameter. Ratio means I'm going to divide. So I'm going to take 12.57 because that's the thing they say first. Divide by the diameter because that's the same thing they say second. Look at there. There's my pi. 3.14. All right, let's change my diameter. Oh, we got to roll it back first. Whoop. All right, so let's go to a 3. All right. So my diameter is a 3. My circumference is 9.42. 3, 9.42. And I bet you $5 when I divide those, I'm going to get 3.14. Yep, 3.14. All right, well, let's see. What do I want my diameter to be next? How about I move it to a 2? All right, so diameter is 2. Circumference is 6.28. 2, 6.28. That's going to divide to get 3.14. All right, about I change it to a 1. 1. Now, if you haven't realized yet, anytime you divide, you get 3.14, which is pi. So my circumference is now pi because my diameter is a 1. 1. 3.14. And when you take 3.14 and divide by 1, you get 3.14. Oh. All right, let's see. I got to have one more. Let's see. I've done 1, 2, 3, 4. How about I just move it to 5? All right, so diameter is 5. 15.71. Divide those, I get 3.14. Oh, that's easy enough. Well, the reason why they had that you do that is because you need to understand that circumference divided by diameter is 3.14. That is where we got 3.14 in the whole scheme of this world. All right, let's see what we got next. What relationship between the circumference and the diameter is suggested by your observation? Circumference divided by diameter is pi. Okay. Question, or part C, sorry. The number 3.14 is a rounded value of the mathematical quantity pi. If you replace 3.14 with pi, what's the exact formula for the circumference in terms of diameter d and the terms of the radius? All right, so circumference is diameter times pi. Oops. Or you can have circumference is 2 pi times your radius. Either one of those formulas is fine. Now, honestly, I use this one if they give me the diameter. I use this one if they give me the radius. So depending on which one they give me is which formula I use. Oh, okay, so that's the end of question 1. We're on to question number 2. All right, now you'll use GeoGebra to explore how the value of pi is related to the area of the circle. All right, so I'm going to click on my new GeoGebra. Oh, it looks like I'm rolling here too. All right, so let's see. Move the slider to straighten the circumference of the circle. Nice and flat. Shabam. Okay. Click the circumference checkbox to see the length of the circumference. There you go. So it's 2 pi r. All right. Dissect the circle by clicking the dissect checkbox. Okay, so it just splits it up into pi pieces. All right, move the rearrange slider to rearrange the dissected pieces of the circle. First, you will see the parts line up on the straightened circumference, and then the parts move into an arrangement with the curved segments and alternate sides. All right, so rearrange. Oh, okay. So it lays out flat. See if I can get it to lay flat. All right, then it just comes over. Interesting. All right, use the lowest slider to increase the number of dissected parts. All right, so right now we have 12. All right, so it turns into a figure. Okay. As you increase the number of dissected parts, the shape they form begins to resemble a geometric figure. Which geometric figure does the shape resemble? Oh, that's a parallelogram. That's a parallelogram. Yep, look at that. Parallelogram. All right, part B. What are the dimensions of this shape in terms of the dimensions of the circle? Okay. So the height is the radius. All right. Let me put that in. Now the length is not the whole circumference. Remember, it came over on top of itself. So let me show you. See, it was there, and it came on top of itself. So it's half of circumference. The length is half of the circumference. Now, the reason why it's just height and length is because that's the area formula for a parallelogram is just base times height. Height and length, same thing. Okay, circles. Yeah, okay, cool. Part C. What is the general formula for the area of the shape that you see? Well, I just said it. All right, so area is base times height, and that's the parallelogram in terms of the dimensions of the circle. Okay, and then the area for a circle is pi r squared. Pi r squared. All right. Okay, so pi r squared. There we go. All right, part D. Based on the formula that you developed in question 3, what is the area of the circle? How do you know your answer is correct? Let's see. So area of a circle, area is the mass inside a figure. So I'll be saying, this is correct because it's not going to change. I'm just sitting here thinking. So based on formula developed, what was the area? Area is the mass inside the figure. And I spelled mass wrong, M-A-S-S. Mass inside the figure. Now I can't really solve it. I don't have any numbers here. So what do you know about the, how do you know the answer is correct? Well, I mean, that's not going to change. I can change the diameter or the radius, and the area is still the mass inside the figure. It's the same parallelogram. Okay, so they basically just say what I've said. All right, so we're done with slide 6. All right, so area formula for a parallelogram is base times height. The formula for the area of a circle is pi r squared, and the formulas for the circumference, depending on which one that you have been given. Diameter times pi, there it is. Or if been given the radius is 2 times pi times the radius. And basically, because 2 times r is your diameter. All right.